So I'm going to start by talking about open science. Open science is just a framework for how people can share and reuse data, other people's data. And it's just a set of best practices which might be required by funding agencies, a cultural thing within the field. It depends on the field, how open science is. And in the open science framework, research objects are what are called FAIR. This is just a set of guidelines and principles made by Force 11. If any of you are familiar with them, they're a group that works on these, giving credit to researchers for the work that they do, including code, data, and other technological inventions that they use. And so the FAIR principles are findable, accessible, interoperable, and reusable. And these originally started with these principles with data, but I'm going to apply these to the Jupyter Notebooks because I think this is, the Jupyter Notebooks are an interface between code and data. And so why would we do open science? There's transparency, there's reproducibility, reuse, innovation, all of these reasons why we, in the open science framework, why you would want to make your science available to the public. And so we're going to talk about our case study is astronomy. I work with astronomers for my work at UCLA. And so astronomy has a rich history of sharing and being open to the public. For example, the Sloan Digital Sky Survey, where they're trying to take a map of the entire night sky. They've been doing this for 20 years. All of this data is open and available to the public. And the astrophysics data system is another repository of publications which is available and is connected to the archive at Cornell, which is also a preprint open repository of publications. Open code examples, there's AstroPy and SunPy libraries that are examples of open source projects that people are working on. And so for Jupyter Notebooks as a tool for open science, I claim that they can be fair if they are in an open repository such as GitHub and available to the public and shareable. And this is a screenshot of Hope and Catherine's GitHub repo of their work that he's going to be talking about. And so my group at UCLA, we wrote a paper on this. We looked at the Jupyter Notebooks that were mentioned specifically in the astrophysics data system. So these are physicists, astronomers, people adjacent to astronomy that are in this repository. And it turns out we found 91 publications. We did this last year. And there were 8 ways of mentioning the notebooks within the publications themselves. So we're looking at just the publications. And this was it's just growing. I mean, if we go on today, there's like almost 200, I think, the last time I checked. So people are citing these in the astrophysics data system. It's happening. And there's no standards for this. People are just doing it because they're trying to give credit or make their work available. And so the ways that the Jupyter Notebooks are cited, they're mentioned. A mention is what is called in the body of the paper itself. We used X library, or our code is available on GitHub, and here it is. And then there's citing the notebooks themselves in a formal bibliographic citation with a number and then the references in the back. And so why would we cite and mention Jupyter Notebooks? To make them findable, credit for researchers, which is becoming more and more important, especially in the open source community where people are putting in all of this work, they deserve the credit. And to be tracked, you can still hear me, right? I don't know if you need a microphone if it doesn't work. And then this has to do with bibliometrics, altmetrics, which some of you might be familiar with, which is which notebooks are being used, by whom, when, how. None of this is, it's very difficult to find this now. And so this is something that GitHub is working on, but it's not perfect at any degree for how this works. And then the measurable impacts. Of course, we would love to know how many people are using Jupyter Notebooks and for what. And this relates to everything at the conference here. Clearly, they're becoming more popular, and everyone seems to be using them at this point. So And then that improves the standards and the collaborations and the sustainability, which is what the keynotes were, a lot of them were about yesterday. So ways that you could cite your notebooks in an open science framework would be, first of all, you would decide what data and code can be shared. Some of your code and data might be private, so you can't, so you might want to decide what you can cite. And then decide on an open repository to put your notebooks, code, and data in. Our example, Hope and their group uses Dataverse at Harvard. Other examples are Figshare, GitHub, Zenodo. And so within the Dataverse framework, you put your data, your documentation, your code within there, and then the descriptive metadata, which comes along with it. And each repository varies on how they do these things, but they're similar enough. And so then you would obtain the DOIs for your, in this case, for these guys, they get DOIs for their tables, their data, their code is in GitHub. You can't get a DOI in GitHub, but you can connect to GitHub with Zenodo, and you can link a DOI from Zenodo to GitHub for code if you wanted to. Paper, you would mention all of these things and all the citations. So the Jupyter Notebooks, DOIs, links, code, the associated data with it. And so in astronomy, in our case study, so this is their paper, which is a draft. It's not released. They haven't published it yet, but they're going to soon, right? And so the best practices for mentioning and citing, so I took this from the AAS, the American Astronomy Association, which is, this is their recommendations on citing code, but I am applying this to the Jupyter Notebooks because I think that it makes sense from a citation point of view. The first thing you should do is you should cite the paper, the mother of all the papers, which is, our dear leaders, Fernando and Brian's original IPython paper, which if you go to jupyter.org, they also ask that this is the paper that you cite. So that's on the granular level, that's the top level of citation. And then you would link to your Jupyter Notebooks or a repository of the notebooks and then cite that as well. So this double layer of how you cite things and then also the associated code, libraries, everything, is the AAS recommendation. And I think that what they're saying is just cite as many ways and as many people as you can to just provide some sort of a searchable, machine, human-readable element that will eventually be able to be tracked. And then people will be able to find your notebooks as well. And then the mentions in the bodies of the papers. These might be in the acknowledgments or thank you pieces. And just what we used, what libraries we used, what code we used. And then also in the Jupyter Notebook itself, these things could be in there as well. Which libraries, which versions, which dependencies are in there, because these are always one of the biggest problems with any of this is what libraries did you use to compute your work and your research. And then the links to the notebooks and the repository. So this is a screenshot of Catherine's Dataverse instance. So notice that each of these tables has a DOI associated with it. You can see that, right? It's kind of small, but. And sorry, the first one is a draft version. So you can obtain a DOI in Dataverse for a draft without releasing it, put that in your paper, publish your paper, and then open the repository. And most of them work that way. I think Figshare does as well. So I am going to turn this over to Hope, and he's going to give a very cool demo of glue, along with what is in his paper.
Hey, I'm Hope Chen, astronomy grad student at Harvard. And at the second part, I'm going to talk about science. That's the thing that we all think is what we're doing, except sometimes we're not so sure. And there are two very important characteristics that form the foundation of science, which are reproducibility and falsifiability, which unfortunately, at least in astronomy, as much as I know, are not being taken as seriously as they probably should. And so first, reproducibility. many speakers have talked about it. It demands open data and open methods, and in our case, the codes, so that people can go ahead, take a look at the data and basically run the same analysis through our codes, and hopefully they will get the same results as we do for a certain paper. But people have to also be able to falsify it, which means that these codes not only have to be able to be applied on one data set, which is ours, but on many, many other data sets that people take at a different time, and they need to be easily accessible as well, so that people can actually understand the codes, modify the analysis themselves, and apply on their own data set. All right, so I'm going to talk about the scientific case in the paper that Bernie already mentioned. So this is the data, what the data in astronomy looks like. It's an image of our own galaxy, except it actually isn't data. So it's artistic rendering of our own galaxy. And in it, you can see that our own galaxy, as far as astronomers know, it's a spiral one. It has these long spiral arms, and the densest parts are these dark spots along the spiral arms where the stars are born and die. But because we are sitting here on Earth, which is in this disky galaxy, what we actually see on the sky is what we call Milky Way, a huge band across the entire sky whole year round. And with telescopes both on the ground, on Earth, and in the space, we are able to map different patches of the sky and combine them together to form an enormously large data sets. So in our study, we actually combine more than a dozen surveys of Milky Way, of different parts of Milky Way, different wavelengths, observations, and with their high resolution images, we're able to hunt for long, skinny structures that are really dense. That's why they are so dark as they appear on this infrared image. They are really long, a few hundred light years long, and they're really cold as well. So this is the kind of object that we think sits right at the center of the spiral arms. That's why this kind of objects is so important. And by studying it, we hope to gain information on the dynamics of our galaxy and how it rotates and how stars form. All right. So one particular property of this kind of object on the sky is the density profile across this long, skinny structure. And so we wrote a set of code, put it on GitHub, and what it does is that, for example, here I have my long, skinny structure. This is a density map. It masks out everything that's actually outside the filament. It takes the cross sections and it matches the peak and extracts the density profile, and then eventually we can use mathematical and physical models to obtain information from the cross section, from the density profile, and in turns we know more about the dynamics of these kind of long, skinny structures, and eventually we hope to know more about our own galaxy and how stars are formed inside of this kind of very dense environment. All right. So that's our data and our codes, and most of the astronomers, what they do today is only to combine them, put them on GitHub, put them on Dataverse, but there's still a lack of how people can rerun the analysis. And as we all know, that there is one tool that allows us to be able to do that quite easily, which is Jupyter Notebook. So besides I should say, along with the journal article that we're modifying and try to get it published, we will also publish, we have already put a notebook on GitHub where other astronomers can test whether the results are correct, whether they can reproduce the same results on their own laptop. Maybe there's a glitch on mine that produces something weird that I don't know, but they can basically reproduce the analysis, rerun the analysis on the same set of data, and they can plug in their own data as well. So I think that's a good point to start. So back to science. Now we've already seen that we can carry out, reproduce the analysis with Jupyter Notebook and the data and the methods that's hosted on the notebook. And with Notebook, people can also apply the same analysis on their own data sets. But imagine that, what if we can get some interactivity? We can play with our own data. They can link another map of the sky and then interact between different data sets. And that's where Glue comes in. And so some of you might have heard of it. I'll give a brief introduction of it. It's a GUI written initiated by Chris Bowman, who's at Netflix now, and is now actively being developed by Tom Robitaille. So it links different data sets. That's why it's called Glue. So here we have the astronomical image and a catalog of a few thousands of stars. And then you can make different plots of it. You can explore the data sets by arbitrarily selecting on the plots you make. And not only that, Glue is not only for astronomy. It takes other data formats as well. Here we're looking at a geophysical data, and it does 3D visualization. And you can similarly, you can explore the data by selecting in any of the visualizations that you make inside Glue. And the team is actually also working with people at Mass General Hospital and try to make Glue compatible with medical data format, and hopefully someday it can save some lives as well. All right, so that's Glue. And just 1 hour ago, I got an email saying that a new version, a more stable version is being released. So that's good news. Cool. All right. So by combining the notebook and Glue, we hope that someday we can write a paper of the future that many other speakers at this conference have already mentioned using different tools. But with Notebook and Glue, I'm going to do a live demo of what this paper of the future can be. All right. Here, let's see. So this is your notebook. You can, of course, write equations, more complicated things there. But what I'm going to demonstrate is that after setting up an environment called MB Glue, short for Notebook Glue, you can get this Glue data container, which is empty right now. I can load my catalog and the image into it. So you see the two data sets are there right now. And then I can link the data so for example, like here on the image and in the catalog, I have the two what we call galactic coordinates. So the longitude and latitude, and I can link them inside the notebook, and it talks to Glue there. And in the GUI, we can actually take a look at what's being linked together or glued together, and I can unglue one of them if I want. And the GUI actually talks back to the notebook, so you can review all the links that's there. You can actually make extra links between different properties in the GUI as well. I'm not going to do that for now. And then I can set up plotting two properties, which is the longitude and what we call the local sidereal reference velocity, which is velocity, basically. And then I can plot them, and then the GUI gives me two windows. They look like normal windows with normal plots right now. But in a minute, okay, before I do anything fancy, I'm going to change the style of the markers. Example, like blue, some transparency, make it larger, and it shows up on the scatter plot. And then because the two data sets are actually linked, I can plot the data points on top of the image, which is a little bit hard to see right now, but I can also adjust the contrast fairly easily like that. So some of you might have already noticed that there's this long skinny structure that I talked about. And then what if I want to select those data points on that happens to be on the this long skinny structure? I can do selection. It shows up as a subset, and it also shows up on the scatter plots as well, because the two data sets are now linked. Cool. So any plots that you make with glue, you can grab it from Notebook, inside Notebook. As I said, the Notebook talks with glue, and glue talks back. So it sends a matplotlib instance back, and you can adjust the labels, the annotations, whatever, even for publication. And it gives you the scatter plot as well. And so believe it or not, actually in astronomy, we found this out. So human eyes are still better at identifying structures, like especially astronomy. In astronomy, you have this kind of random, arbitrary structures than machines, at least for now. So it is actually quite important that the mask, the subsets that's being made inside glue, can be exported back to the Notebook, and then I can grab the mask as it is here, and I can again make whatever plot I want to make simply with matplotlib. I can do fancy things, so the data points are now stars in there, and hopefully someday this can be expanded, and together with the widgets and other tools, the Notebook can be made into a better environment for publishing not just the data, not just the code, but a complete article together with the analysis. Okay, it's demo time. And the code that makes it possible for Notebook to talk to glue and back is made available. It's under heavy testing right now, so it's called NB-glue on GitHub. You can look it up. And then, so with the end of the demo, I think Bernie and I can start taking questions. Thanks. What do you mean? Right, so I don't know if you're at, I can't remember, one of the talks this morning. So people always think that interactivity and reproducibility conflicts with each other, right? But I want to stress it again. Jupyter is this platform that allows you, so I put my code, exactly the same code, the same setup inside Notebook. I've linked it with the open data that I put in Dataverse. I am only allowing the users to have this kind of interactivity to make sure that I'm not doing anything sketchy. There's nothing special about those setups. But they can still use the same setups to reproduce my results. But they can, of course, change it. I mean, what if I select some special star which happens to be some way rather than the other, but there's actually nothing special about the star. So that's, I think. Oh yeah, sure. So so as I said, what it works at least as I understand of it right now is that you can save those masks as some data formats, as a image format, as a some Boolean arrays, and then you can export it, and then Glue can take those in again, and I can reproduce it. I just didn't very strictly follow it just now. So yeah, thanks for that.
No, we all we were trying to do was to see if they were fair. So were they findable, discoverable? When you clicked on the link, did you hit a paywall? Did the link even work? So we did not even examine whether they ran. Which, by the way, that's a pitch for for your talk. That's what these guys tried to see if the notebooks would even run, with interesting results that you can find out later. What time is your talk? 4:10. But no, we just wanted to see if people were making these things available, because previous studies before the notebooks, what researchers used to do was just link to stuff on their server at the university, tilde, last name. And one of those studies, they studied thousands of papers from the ABS that had links to data on university servers. And it turns out almost all of them were broken because professors move from university to university, so it's a huge problem. But this was in 2010, 2005, whatever. So this is all before GitHub and all of these open repositories that they have now. So it's still a problem. People link to one of their notebooks in GitHub, and then they forget that they published that. And then they'll move their folder, or whatever else reasons that they would have that these things aren't findable. Go ahead.
All right, I think, do you want to?
No, you
Okay,
can.
so I think many other speakers also mentioned this, because it's still a little bit hard to imagine that a full journal article paper can be written in something like Jupyter Notebook because of what? Yeah, it's almost there, right? So I think, yeah, actually you can put in like equations right now. You can make plots there. You can, people are making books of it.
Yeah, I mean, I think one of the big reasons is the journals themselves. They're locked in 100 years of tradition. They, PDF, and everyone is saying, well, this static PDF is so archaic, and so there's no reason. You can, but then you've frozen all of your interactivity and your. I mean, you can. It doesn't look that good actually when Markdown is not great, but it works. I mean, you can make it into a presentation too.
So I just want to add. I think at least in astronomy, the American Astronomical Society is making it more and more likely that their journals, the astrophysical journal, is going to take notebook more seriously and actually allow peer review and allow citation, as Bernie has already mentioned. And yeah, I think it's about setting up a standard.
Yeah, so this is interesting. So the lead Glue developer, Tom Robitaille, he's on the board of the journals for the American Astronomy Association. And he told me this. He said he is going to reject submissions if people are not citing code, notebooks, or software. So he's saying we have to give credit to people. And so that's someone who's on the journal board. So I think that's a big necessity, is to change the way that the publishers are doing this and allow them to accept. Because in some fields, and I've heard this before, not in astronomy, but they won't even allow a Jupyter Notebook to be cited within the paper. They take it out. So it's, you know, as a researcher, how are you supposed to cite these things if the journal article it's taken out of there? So this is a cultural change that needs to happen. I have not heard of that. Has anyone? Like a proper citation reference, like how, you know, like how you reference a magazine versus a book, Jupyter Notebook. I've not seen it. I know that the people, like Force 11 people who are working on this, they're still bogged down with how to cite code and software, and like what versions and how granular and how many people, and you know, and that, so I think everyone's like, yeah, that's a good idea, we should do that. And I mean, right. And some people don't even think Jupyter Notebook should be cited. They think it should be a Docker container containing everything. So, I mean, you can, maybe we won't do that. I don't know. That's a great question.
So, if there's time, I actually also want to, speaking of cultural change, the question just now reminds me of a conversation that I had with Tom Rothkow the other day. Because now for journal papers, we have this linear hierarchical authorship. But if you're able to, in some way, you can look on the GitHub and knows who does what, right? Like who actually carries out what kind of comments in a notebook in the code. And Tom said that maybe someday we can have a more organic authorship, and it's not just the big boss in front and then all the postdocs and students at the end. So I think that's also one cultural change that would happen, hopefully.
And that's why it's the paper of the future, not the paper of now. So I think we're done. Yeah, thank you. Thank you for
Thanks.
coming.